Okay, so I know people are still coming in, but that's fine. We don't mind. We'll just get started now because we've got so much stuff we want to pack into 60 minutes. You know how it is. We have no time for pleasantries or whatever. So I'm Steve, and
I'm Ryan. I'm the other guy.
Yes, the other guy. All right, so we work together. We're both at Microsoft on the ASP.NET team, and we are two of the people who are mainly responsible for designing what you see in the Blazor programming model today, and Ryan's got extra special powers when it comes to compiler stuff. So if there's stuff you don't like about it, then you know who to blame, and we don't care, but you can come and tell us anyway.
Yeah. If you found a bug, you can ask us, and I'll tell you whose fault it is, if it's Steve's or if it's mine.
Yeah.
It's probably his.
I'll give you a clue. All right, so we're going to get started, and in this talk, you're going to get a bit of a two for the price of one thing, because we're going to go through two different subject matters that we think will be really interesting to you if you are a little bit more on the advanced end of the Blazor developer spectrum. I'm just going to get started pretty much straight away with the half of the talk that I'm going to focus on.
And I want to mention that I haven't seen yours and you haven't seen mine.
Yeah, that's right.
So if an argument breaks out, it is genuine, because this is all going to be new to me.
Yeah, they may flatly contradict each other. So my part of the talk, so imagine that, firstly, you know that Blazor is a component-oriented framework, right? You build components and you construct your application out of that. If you're a little bit more advanced, you may also know that part of the design of this system is to let you put your components in packages and reuse them and share them across projects, and to even publish them to NuGet and make yourself into an open source superstar. So that's what I want to focus on now. I want to give you some tips on how you can build a really nice Razor class library that packages up Blazor components that you can share. And it might be that you just want to share them with other teams within your company. It might be that you want to share them with the public in general. Or even if that's not the case, it might just be that you want to make things really good for your future self, so that when you come to another Blazor project in the future, you can make use of stuff that you made in the past in the most sort of convenient way, and you can think, oh, I was a genius for designing it in that way, and it's so nice to reuse now. So the scenario I want to cover, or the example case that I'll be using for a Razor class library, is to do with building charts, graphs and pie charts and all that kind of stuff. And I think it's a good fit for a Razor class library because you wouldn't probably expect the Blazor framework to have built-in graphing features, or I hope you don't, but you probably also wouldn't expect to write that code yourself by hand. You probably think that you're going to get some third-party package that gives you graphing capabilities. So that's what we're going to do for the next 20-25 minutes or so. And the particular way that I want to approach this is by showing you how we can wrap up some functionality that's provided by a third-party JavaScript library. So there's this thing called chartist.js, which is a really nice way of making graphs and charts, but it's for JavaScript. And what if we want to make a really nice set of Blazor components that follow all the kind of most convenient API patterns so that our users can have a really fun time making some charts and graphs?
Now, Steve,
yeah?
I have a question.
I
heard that WebAssembly is like antimatter for JavaScript, that it like eats JavaScript. Is that true?
Does WebAssembly eat JavaScript?
Yeah.
You can use JavaScript from WebAssembly. What else do you mean?
I guess I mean like there are obviously lots of like JavaScript components that are out there that are still useful.
Oh yeah,
right?
yeah.
So like it sounds like all that's needed is somebody has to make a Blazor wrapper for that JavaScript component, and then people can use it without even knowing, how it's implemented.
Yeah, that's absolutely true. Yeah, so if we give some nice .NET API wrappers to whatever kind of underlying functionality we want to use, then you can consume that very nicely as a .NET developer, and you didn't really need to know or care how the underlying implementation worked. So how can we do it? Well, I'm going to give you 8 steps to success. And we will start with a very basic one, which is just how to create and run a Razor class library in the first place. So over in my IDE here, you can see that I haven't really got started yet. I've got this empty solution with just this folder in it. And I want to add a Razor class library. You may have done this yourself, but if you haven't, you can do it through the Visual Studio project creation dialog, or you can do it on the command line. There's a way of doing that there. But I'm in VS, so I'm going to start searching for Razor, and we get Razor class library. And we'll go on from there. I'm going to put it in a particular place, and I'll call it Blazor chartist, like that, because that's the thing that I'm doing. And then when I hit on create, there's one option that I want to point out to you here. There's a bunch of options, but the one that I think is the least obvious what it even means is this one, support pages and views. So what that means is, what we're talking about when we say pages and views here are MVC views and Razor pages. So those are not Blazor technology. These are a different type of Razor class library, and that's not the one that we want, because we want to build something that works in all Blazor environments, including on WebAssembly, so we don't want to tie it to Razor pages or MVC views, so we're going to leave that box unchecked. That's just the one tip that you need to know. Okay, so we create our Razor class library, and then we'll have a look and see what is in there. And what we do find in there is a bit of example stuff. So we've got a Razor component, and we've got some static files as well, because Razor class libraries can contain components as well as static assets that you will use from those components. Okay, now before we do anything useful with this, we need to have some way of running it, and I can't run a Razor class library on its own. It's just like a .NET class library. We need to have some kind of application that it runs inside. And so what I usually like to do when I create a Razor class library is to create a set of sample projects that show how it can be used. Now, do we want to use a Blazor WebAssembly sample project or a Blazor server one? Well, if we are being ambitious and we want to make the best possible class library, we want it to work in all environments. So how about we do both? So I'm going to add a couple of sample projects right now. And in this talk, I'm not really going to have time to type out everything by hand. So I'm going to use Git to jump backwards and forwards to different points in the history of my project, so we can accelerate our progress a little bit. So now you'll see that I have got this samples directory alongside my source files, where I've got two different actual runnable projects, a WebAssembly and a server one. Now I'm just going to start up this WebAssembly one first before I tell you how this stuff is set up. So I'll start that going in my browser right now. And when that comes up, you should see it's pretty familiar. It's the typical sort of file new project Blazor thing. What have I changed about it? Well, I've removed a couple of the pages because I don't really need them. I just want to render one component. And I've also got this little bit of a text up here saying what environment I'm running in. And the way that works, if we go to our, where is that? It's probably in, is it nav menu? It is. Okay, so here's the implementation for that. I'm using this runtime information API to check where we're running and displaying either WebAssembly or server. Okay, now I've also got a server project, and if I start that up, you'll see what comes out of there should also be very familiar to you, because when that appears, you'll see it's exactly the same as what we had before, except this time it says env server. So to save myself a little bit of time, I don't want to have to keep copy and pasting code between these two samples. I've actually referenced the WebAssembly sample from the server sample. Maybe you didn't know you could do that, but you can. And then, inside my host page on the server here, the actual root component that my server page is rendering is the same app that's coming from the WebAssembly sample. So I'm treating my WebAssembly sample as if itself was a class library, and I can just reference one of my applications from another. It just means these two applications stay in sync with each other, and I don't have to duplicate any code. Okay, but what I actually want to do is use some of the components from my Blazor Chartist project. So I'm going to go to this index page, and I'm going to get rid of that, and I'll try putting in a Blazor Chartist component 1. Okay, and that is what has just come out of my project template. Okay, so let's start that going, and we'll see what that renders. Well, by default, it renders this little bit of text, which is not super interesting. If you're wondering where that comes from, well, that comes out of our component 1 Razor file. So that's doing exactly what you might expect, with the exception that you'll see we've also got this CSS class. What is that CSS class? Well, that is wired up to this entry in our styles.css file. So you see we've got a particular border and a background image and stuff. So you might be wondering, well, why is that unstyled then? Why didn't the CSS stuff apply to it? And the answer is because I didn't reference this style CSS file yet. So if I'm a consumer of this Razor class library, I need to choose which of the static assets in it I want to consume and where in my page they should appear. So I'm adding that reference with this particular URL format now. And if you're wondering why the framework doesn't add that for you automatically,
I was just wondering that.
That is exactly your question, was it?
Yeah.
Okay. So the reason, we did used to do that, by the way. We used to add the references automatically, but we found it wasn't practical in the real world because you need often to let your user choose which of the static assets they want to use and choose which order those references should go in. And the framework can't know that sort of thing. So if you're the class library author, you're going to have to choose for yourself and document what references people should add. So now, anyway, you can see I've added that reference and my styling shows up. Cool. All right, so that's the very, very basics. Now, how are we going to bring in this third-party JavaScript stuff that we want to use? Well, I've already done it. So let's jump forwards, and I'll show you how that can be achieved. And now, in my project, you'll see I've got these files, chartist.min.css, chartist.min.js, and I got those by literally just downloading them from the Chartist project website and putting them into my project. And that is not really the best way to do this, because now we have to deal with figuring out the versioning manually and updating manually and stuff. And I'll show you a better way we can approach this later, but we're just getting started. And I've also got this Blazor Chartist.js where I'm going to write my own code. I've also got chart.razor, and you can see in there what I'm doing is just rendering a bit of fixed markup, which I'm deleting, and I'm also using a Blazor feature to capture a reference to that div so that I can start passing references to that into JavaScript. Okay, so I want to use that now to actually render a chart. At the moment, it just displays this, this little message there that says, tell Chartist to draw a chart. So how do we make it draw a chart? Well, we probably will go to the website for Chartist.js and see what the API looks like. And they're going to explain it to us in terms of JavaScript. And they will tell us that the thing you need to do to render a chart is something like this. So you'll new up an instance of Chartist.line and pass an element to it, and also pass a bunch of data that you want it to render. Okay? So as you can see, it's just hard-coded stuff right now. But let's see, can we actually call that in the first place? How do we call this create chart JavaScript function and pass an element to it from our Razor component? Well, we can do so using a pattern that you see a lot in Blazor applications, which is that we use ref to capture a reference to the element, and then inside the onAfterRender lifecycle method, if this is the first time we've rendered, then we can use JavaScript interrupt to call this method, and we can literally just pass the element directly from Blazor into JavaScript. So if you're wondering why that should be onAfterRender and not, say, onInitialized async, the reason mainly is because we're trying to use this element. And that element doesn't even exist until we've rendered. It's something that gets produced by the rendering process. So we can't use it until we've rendered. Therefore, we're going to put this into onAfterRender. There's another reason as well that I'll get to later on. OK, so assuming that stuff works now, does our JavaScript code get run, and do we actually render some charts inside the browser? Let's see. The answer is yes. We are now successfully rendering a little graph, which is cool. Okay, so we've successfully brought in some third-party JavaScript, and we've invoked it. But so far, we don't really have any proper API. There's no way for our package user to specify what data it is they want to render. How can they give us their own chart data? Well, let me show you. So I'm going to define a few extra C# class files to do this, and I'll show them to you right now. So you'll see I've now got this data directory here with a bunch of C# files inside it. For example, I've got chart type, which is an enum. I've got these two, and I could add support for other things later if I wanted. I've also got chart data. And chart data is you define a set of labels, which are the horizontal x-axis labels. And we can also define a set of series that we want to plot. And each series is something that's got a name and some data. Okay, now, I've also added onto my chart component some parameters. So you can now pass what type of chart you want it to render, and you can also pass an instance of chart data. And then, when we first create the chart, I'm passing the type into JavaScript, and also every single time this thing renders, which includes every time the data on it changes, we're also going to call this JavaScript method updateChart and pass that data. And the implementation on the JavaScript side looks like this. You can see the code later. I've published it to GitHub. I'll tell you about that. And if you look inside the update chart, you'll see it's taking that data and it's passing it through. OK, so how do we actually use this now as a consumer? Well, I'm going to go back to my index page. And you see I'm not passing any data just yet. But I want to pass some data. So the sample data I've got looks like this. And as you can see, I'm investigating a certain conspiracy theory that I'm working on at the moment, which is that maybe the global oil crisis caused Trump to tweet more, or maybe the causality goes the other way. I don't know. I haven't decided what my conspiracy is yet, but I'm going to look at the graph and try and figure out what it is. Okay, so I want to render some charts now using that data, so I can simply pass the data using these parameters that I've defined. So all being well, we should now be able to plot these two series side by side and compare them. So back in the browser, reload, and you'll see we've now plotted these two graphs, and we can try and figure out, what the theory about the conspiracy is. And you could argue there's no real correlation, but I don't know. I'm still going with my conspiracy theory on that one.
I'm going to punch up some of my examples on the fly.
Okay, right.
Add some Boris jokes to them.
Okay, yeah, that sounds good. Thanks. Just try to mention Brexit as many times as you can. Okay, so we've got a couple of charts. That's great. Good for us. Well done. But so far, we've got a very, very basic API, which is not very good. It's not very idiomatic for Razor. If someone is consuming this, they will not feel like they're having a particularly luxurious experience because they have to define all this code down here. Wouldn't it be nicer if we could do it in a more Razor-like way? For example, we can pass a separate parameter for the labels, like up there, and maybe instead of defining the series as an object literal, we could have a syntax that looks like this, series, and then we could start defining stuff like that. That would be more Razor-y. So how can we make a better API like that? Well, first thing is I'm going to go over to my chart.razor, and I'm going to start adding an extra parameter. So I'm going to say you can pass some labels. But because this is a nice API, I'm going to say it's optional. So I'm going to say if labels is not equal to null, then we're going to use them. And if the labels is not equal to null, then I'm going to write them onto this data property like that. So now it's optional. If you want to pass all the data as one blob like this, you can. And if you want to split it up into separate parameters, you can. Now, I'm just overwriting some data that the user passed in, which is arguably not the friendliest thing. But it's a reasonable approximation to what we want to do right now. So now back over here, I can make sure that I've rebuilt everything. And then hopefully the labels property will show up in Intellisense. And I can start passing my labels in. And I'm going to do the same thing down here as well, and now I don't even have to define it there at all. So that's a slight improvement. Next improvement is, like I said, I don't want to have to define this object literal anymore. I want to be able to use declarative Razor syntax to specify the series. So how do we do that? Well, in order for something like this to work, we're going to need to define an extra component that's actually called series. So let me show you how we could achieve that and make it interact with the parent component. So I've added a new class now. Well, firstly, you can see this is what the resulting API is going to look like. You can see I don't have that object literal at the bottom anymore. So I think this is a bit nicer. And I'll show you some advantages of that in a minute. But the actual implementation of it looks like this. So you'll see I've got this class now called series.cs. And that actually is a component. Now, normally when you create a component, you do so using a Razor file. And that's great. You could totally do that in this case as well. But a Razor component is just a class after it's been compiled. So if you want to, you can define it with a regular CS class file just the same. The only difference is, if you use a regular CS file, you don't really have any way of defining the rendered markup because you're just using C# code. But that's fine because this is going to be a data-only component. It's not going to render any visible output. It only exists to supply data to its parent. So I'm showing you that we can do that with a CS file if we want. And the syntax inside there is more or less the same as before. So we've, again, able to accept parameters for the name and the values. We can use the same lifecycle methods. So when the parameters get set, I'm going to build up one of these series data objects. I'm also going to receive a reference from the framework to the owner, the parent component, which is being cascaded down. And you can check the implementation later if you want to see exactly how that works. And then when this thing gets initialized and added to the UI, we're adding the series to the parent. And when it gets removed from the UI, we're also removing the series from the parent. So as long as I've done everything correctly, I should be able to rebuild and reload in the browser, and everything will behave like before, which it does. But we've now got a nicer API. And then one of the ways in which this is a nicer API is that the person consuming it can do stuff in a more programmatic, a more declarative way. So previously, if I wanted to make my series toggleable on and off, the user would have to write lots of code to add and remove stuff from data structures. But if we do it with Razor syntax, it can be done declaratively instead. So let's say that I want to have an ability to toggle Trump's tweets on and off. Okay, so I'm going to take that Boolean and I'm going to say, just using normal Razor syntax, if we want to show Trump tweets, then we'll have that series there, and if not, then we won't. So it's really easy to use. And to make that actually toggleable, I'm going to simply wire that up to a checkbox that's bound to that property. Okay, let's check that this really works. So back over here, I'm going to reload. And then now you'll see we've got this checkbox, and as I toggle it, then that second data series will go on and off. So that's the advantage of using a nice idiomatic razor-type syntax, is that the person using it can do all kinds of things to change what's going on at runtime without needing to know about your special APIs. Okay, another thing that we can do to make our APIs even better. What if I wanted to add some kind of tooltip to these charts or some extra CSS styling? It's not completely clear how I could do that as a consumer right now. I could try to do it as follows. For example, I could try adding a title attribute and some CSS styling that's hard-coded there. Let's see what happens if I try and do that right now. Well, if I do that and I hit reload, then what happens now is we get an unhandled error has occurred. And if we look at the reason for why there's an error, it's because object of type chart does not have a property matching the name title. So by default, the person consuming your component can only supply attributes that you've declared a way of handling. But if you're a high-quality component author that wants to provide a first-class experience to your users, maybe you're going to make something like this work. So we can't anticipate every possible attribute that someone's going to supply to us, but we can handle them all in some default kind of way. So what I'm going to do is add an extra parameter to my component, which uses this special API capture unmatched values. And that's going to let the framework build up a dictionary of all the extra attributes that have been supplied that we haven't defined any handling for. And then I can choose where in my rendered markup I want them to go. So I'm going to use this syntax, attributes with the @ symbol, because it's a directive attribute, to add all these extra attributes to my rendered output. So now that I've done that, instead of the thing that I did before being an exception, we'll see what comes up. This time, in fact, it works, and you'll see we've got that faint yellow background, and if I put the mouse there, you'll see that our little tooltip actually shows up. Okay, so we're treating our users with a lot of care and allowing them to do whatever kind of thing they want. They can they can pass different combinations of parameters, they can use razor syntax to pass data declaratively, and they can use arbitrary attributes in order to control the rendered output quite nicely. Okay, so we've got a nice API now. If we're going to continue with this sort of goal of providing the most first-class service we can, then how about we make the Intellisense better as well? I'm sure many of you know that with C# you can add inline documentation that will show up in Intellisense. What not everyone seems to know is you can do that with Razor components too. So right now, in the IDE, if I'm consuming this stuff and I hover the mouse over chart, what does it tell me? Nothing really, it just says it's a chart, have fun with that. And if I hover over labels, it just says, oh, it's an enumerable of string, great. There's just no real information being given to me. But the editor supports XML comments. So I could go to my series class right now, and I could use this / syntax like that, and then I could fill in a bit of summary text. And you can see we can have these strongly typed references in the documentation from one class to another. But it's not just CS files. I can also do this from a Razor file as well. For example, let's say I want to add some information about this labels parameter. So I'm going to drop in some text for that. You know, it's the x-axis category labels. Okay? So now I've done that, if I go back over here, and we try doing this stuff again, I hover over series, and you'll say now it's got that information that I just added with the nice namespaced reference, and if I hover over labels, we'll get this message that we've added. So it's a very small and simple thing that you can do, but it hopefully gives a better experience to people consuming your library. Okay, what else? Okay, let's think about compatibility a little bit. So far, I've been running exclusively on Blazor WebAssembly, but does this stuff actually work if we're running on the server, even though we're doing JavaScript interop? And what do I even mean by compatibility with pre-rendering? Well, let me explain that to you. Well, firstly, let's check, does this work if we run on the server? So remember that we've got this server sample. I'm just going to get that to run now. And you remember I've wired it up to the WebAssembly sample so that it always renders the exact same output. So if I start that up now, you'll see we're running on the server now, but we have the same behavior as before, the same toggling, the same styling, the same tooltips and everything. And we can see and easily test that our component works equally well on the server. And if you're wondering what it takes to make a component that works perfectly on the server too, there's pretty much just one rule that you need to follow, which is to do with JavaScript interop. When you're running on the server, all the JavaScript interop is taking place over a network connection, and therefore it can only work if it's asynchronous. So if you're using JavaScript interop APIs, make sure you only use the async ones. And that's quite easy to do because, by default, that's the only thing that we actually let you do for this exact reason. But there is a way of not doing it, and I'm just telling you not to override us. So you can see this JS interface here. It's got invoke async and invoke void async. If you use those, then you are safe. Your code will work on the server as well. There's a way of doing synchronous interrupt, which I will not show you because I don't want you to do it. And if you do that, then it will not work on the server. So just don't. What about this pre-rendering thing? What do I mean by that? Well, when you're running a Blazor application, particularly if you're running it on the server, but you can do this with WebAssembly as well, we also support server-side pre-rendering. So the actual initial markup of all your components gets resolved on the server and sends down to the browser. Now, my application doesn't actually do that just yet. If I look inside my rendered HTML, you'll see at the root here, we're rendering this app element, and there's not really any content inside there. There's this massive comment block, which is how the server and client stuff gets wired up together. But there's no pre-rendered markup in there. If we want to do server-side pre-rendering, it's pretty easy. You can go to the component tag in your host project and change this render mode. In fact, the default render mode is server pre-rendered, but I turned it off just so that I could demo this like that. If I change it into server pre-rendered mode, then we're going to get slightly different output from the web server. So if I come over here and hit reload, then now instead of that comment block, or as well as the comment block, we also get all the initial markup that's rendered from our components, including stuff like this, which you'll recognize is coming from our chart component. And everything works together at runtime, so when I reload, the browser initially sees the pre-rendered HTML, and then the interactivity takes over. So what does it take for you to ensure compatibility with the pre-rendering mode? Well, there's basically just one rule for that as well, which is also to do with JavaScript interop. Because when you are doing JavaScript interop, you need to understand that that does not make any sense during pre-rendering. Because during pre-rendering, there is no browser, therefore there is no JavaScript, therefore you can't interop with any JavaScript. So if you want to do JS interop, make sure you put it in the onAfterRenderAsync method and not inside onInit or onParametersSet, because all the lifecycle methods run during pre-rendering as well, except for this one. The onAfterRender ones do not run during pre-rendering, therefore that's a safe place to do JavaScript interop. And thankfully, that's also the only useful place to do it in many cases. So as long as you follow that rule, then your class library will be compatible with all three of these environments. Okay. Right, then, we're down to our last couple of tips that I want to give you now. The next one is to do with how we're dealing with these static resources. So at the moment, you will remember that I put these Chartist files directly inside my project, excuse me, which is fine. It's a very basic way of doing things. But we're missing a few features here. Like, how do we get updates to newer versions of it? Also, how do we do things like bundling and minification of our resources? And what if I wanted to write my Blazor Chartist JS file in TypeScript rather than JavaScript? Well, to do that sort of thing, we would want to have something like a Webpack and TypeScript build process. Now, I know many of you may be thinking, hang on a minute, Webpack and TypeScript, the whole reason I'm using Blazor is to avoid those kind of things, right? So that's kind of the point, right? So if you're the component class library author, then you're the one who's taking on the complexity of dealing with things like a Webpack build system so that your users don't have to. You're the hero in this story. So let's be the ones who add the Webpack build system, and then we can get the benefits, and our consumers don't have to even know what's going on with that. So I'm going to jump ahead again to a Webpack build system. And if we look inside the project now, and we dismiss these helpful notifications, then you'll see I don't have a www.root directory anymore. I've removed it. What I've got instead now is this static assets folder. It doesn't have to be called that. I've just made up this name. And inside there, I've got some stuff to do with TypeScript and Webpack. For example, I've got Blazor Chartist TS. And that is a TypeScript-based version of the same code that you saw me write before. It's a bit longer because it does all this extra type checking stuff and it's classes and things now. It's also quite cool because it's importing the Chartist library from NPM. So I don't need to have a separate reference to Chartist anymore. I can just declare what version of Chartist I want to have inside my package.json file, and I don't need to have its actual files inside my project, so that's nice. Then in order to actually build this stuff, I've added a simple Webpack config. If you're familiar with Webpack, you'll know this is a fairly straightforward one. If you're not, then you can just find this code and copy and paste it later. It's pretty straightforward. It's just using the TypeScript loader so that it knows how to read TypeScript and it will be able to compile that. Okay. And then finally, I've chosen, just to be a bit ambitious, to integrate this with the default MS build system. You don't necessarily have to do that. If you want, you can create a Webpack and TypeScript build system that you just manually invoke from the command line. You can just go to command prompt and start running npm install and Webpack build and things like that on the command prompt. But I wanted to see what it would look like to really integrate that with MS Build. So I've made these really awful targets files that do things like, if the package lock has changed, we'll run npm install automatically. If your TypeScript sources, we'll rebuild, and we'll also automatically copy the CSS out of the Chartist package into our project. So if I build that now, then you'll see this www root directory has now appeared, and if we look in there, this is the output. We've copied the CSS out, and we've copied this JavaScript file out, and this is bundling everything together. So I've got my code in here, and I've got all the Chartist code. And so if I just run my project again now, then everything should work the same as before. If I reload, then everything is still working. Great, that's wonderful. And that's coming out of the build output. But you may notice a couple of things, like what about the fact that this is not minified right now? Well, that's going to be not optimal in production. Well, don't worry, because we can set up all the necessary parameters for that. So if I change myself into release mode now, and I do a build on this, which I will in momentarily, then this time, because of all those targets, it will say, something has changed, therefore I'm going to rerun Webpack, which I wouldn't have done otherwise, and we're doing it in production mode now, so you'll see we've now got a minified version of the output there. So we've automated all these manual steps that we would normally have to do, which is pretty nice. I would say it's an absolute ordeal trying to figure out this stuff. So I would try and find some example that you can copy from if you want to do this kind of thing. And of course, I'll be publishing the code for this project if you want to check that out later. Okay, so that's adding a Webpack and TypeScript build system. We've got a nice class library now. It's got a nice API. We've got a nice build system for it. And finally, we're going to want to actually publish it and share it with the world. You can, of course, do that manually. You can run .NET Pack on the command line. You can get a NuGet package, and you can manually go and start uploading that to NuGet.org if you want to. But it's a bit of a pain to keep doing that. Every time somebody sends you a PR and you merge it, you then have to go through this process all over again. Wouldn't it be nice if you could automate this process a little bit? If you could continually deploy every commit as a new package to NuGet.org. That used to be really hard to do, but it's actually quite straightforward to do now. So if you've not seen how this sort of thing looks, let me show you. There's probably several ways you can do it. You could do it with GitHub Actions or some other kind of CI system. I'm going to do it with Azure DevOps right now, just because I'm familiar with that, and because also it's free if you want to, as long as you're not building your project too many times, which we're not. So my definition for how that works is this YAML file. And it's got a set of steps in it. It says first, we're going to choose which .NET SDK we want to use. We're then going to run a build to make sure that everything is happy, including all the samples. And then if that passes, we'll run .NET Pack to produce the actual package file. And assuming that all of this stuff has succeeded so far, and that we're on the master branch, then we are going to push that up to NuGet.org. So when you create one of these config files like this, probably by copy and pasting an example, then you can go and configure that with Azure DevOps. So you create a project on Azure DevOps, and you point it to your source files on GitHub. And it will find the YAML file in there, and it'll say, do you want to use this as the build definition? And you say yes. And once you've done that, it will start watching for all the commits that go into your project. And whenever a commit occurs, it will run that pipeline and build your stuff. So you can see it's been building every time I've done a commit on this. And if we look inside there, you'll see all the different steps within my job that I've configured, such as the one that automatically publishes to NuGet.org. Here you go. This is where it's actually pushing this file to NuGet. Okay, so that being the case, if I go and look at my project page on NuGet.org, you'll see that we've got all these different versions of it that have been automatically deployed to NuGet every time I've done a commit. And I'm actually quite scared that people have started to use this thing already, which was not intentional. This is just a demo, and it has very limited functionality. But
everybody go use it.
Yeah, don't send me bugs. I'm going to disable the issues on GitHub, so you can't. Okay. So there you go. Those are my recommended 8 steps to success as a Razor class library author. I hope that's useful to you. If you want to get the code for this example, then you can go to this URL, and obviously you'll find all the stuff there. So with that, I'm going to hand over to my colleague, and he's going to wow you with some other stuff.
I'm going to trip you with this power cable.
Right then. There we go.
Okay. Okay, great. We're live here. So Steve introduced me. I'm Ryan. I'm, of the two of us, maybe the compiler-focused person, or the sort of compiler whiz kid, or maybe mad scientist is a more appropriate term. And I wanted to talk to y'all about some compiler stuff, mostly because I think it's cool and I think it's interesting. So hopefully you do too. So about me, developer and architect on ASP.NET Core. I've worked on pretty much everything in ASP.NET Core for the last couple of years. Really had the pleasure to be involved in the Blazor effort, and maybe spent about a year to a year and a half working on compiler and language features there. You can find my presentation materials from this and other talks at that location after this is done. So agenda for today, I'm going to be talking about, I'm going to spend 30 seconds saying what is a compiler, just in case anybody didn't learn that in computer science school. Pretty easy to grasp. What's special and unique about the Razor compiler, or what we're doing for Blazor. And then we're going to look at some code, and we're going to try and put it under the X-ray and understand it a little bit, and see, examine maybe in detail some language features, or what the compiler's role is, or what the steps are. You won't need this information. You might be somebody who likes to learn this way. You might be somebody who's like, oh man, this is blowing my mind. If you're the kind of person that likes low-level concepts, I think you'll appreciate it and enjoy it. I hope it's fun and it's interesting for you, even if it's not useful. But I know some people out there really like to learn things from first principles, so maybe this is helpful for you. I'm not going to promise that it's not, but I do hope that it's fun. And so in order to talk about what to do today, I'm going to date myself pretty severely. So you can choose your metaphor for what we're going to look at this today. I've got 2 options for you. We're going to look at the code and try to see the high-level details that are buried in all the code. Or this is either going to be like an old-time cartoon where somebody walks in front of an X-ray machine or gets electrocuted, and you get to see all their bones and see all the things inside. So Simpsons and Matrix, maybe dating myself a little bit there, but that's kind of what I hope you're going to get out of today. So what is a compiler? What does a compiler typically do? Well, there's a set of steps that a compiler typically goes through. You start with the source code, or the things that you typed in, or libraries that you pull in. The compiler is going to read all that text, and it's going to build an understanding of that. We typically think about that as a syntax tree, or like a sort of tree representation of the code that you've put in. Most compilers nowadays are then going to transform those syntax trees into an intermediate representation. The intermediate representation is going to be a little bit closer to what the compiler outputs, and usually is a useful data form, a more useful data form than a syntax tree for what the compiler's job is. And then lastly, the compiler produces some output after running a series of transformations over the intermediate representation. So that output could be native code, it could be IL, it could be JavaScript in the case of the TypeScript compiler, or in the case of the Blazor compiler, it could be C#. So introducing the Blazor compiler, or the Razor compiler, they're kind of one and the same. The job of the Razor compiler is to take your C# code, your compiled assemblies that are your references, and your CSHTML or your .razor files, and it actually produces C# on the other end. We don't produce .NET IL directly. We produce like valid C# code that could actually be edited and compiled by the vanilla C# compiler. So walking through those steps from the point of view of the Razor compiler, we're going to read your CSHTML or Razor files. We're going to build those into syntax trees. These syntax trees don't just represent one language, which is kind of spooky, because an HTML document or a CSHTML document or a Razor document has got that mix of C# and Razor. So we actually build syntax trees that contain multiple languages and sort of embed and transition between those. In Razor, you can have C# in HTML and C# in HTML. You can have nesting. Then we turn those syntax trees into an intermediate representation. Our intermediate representation in Razor and in Blazor actually is pretty close to a generated C# code. It's pretty close to a C# class. So our IR represents structural concepts like classes and parameters and properties and methods, as well as representing output concepts like markup or expressions or binding or things like that. So your Razor and Blazor level primitives are expressed in the IR or represented in the IR, as well as a bunch of C# detail stuff like what is the name of the class that's going to be generated. And then lastly, we output generated C# code. So we literally write C# files to disk and then run them through the normal C# compiler in order to produce something that's runnable. So some things that make the Razor or Blazor compiler kind of special and kind of unique and kind of tricky. We have to parse and recognize the structure of all the HTML that you've pasted in. Some people may know that a difference between CS_HTML and Razor is that CS_HTML is text. So when you have an MVC view or an MVC Razor page or something like that, the runtime is actually treating the HTML as text. It knows very little about the structure of that HTML, and you can do all kinds of invalid stuff, or I guess maybe not well-formed stuff is a better, more precise term. And the compiler and the runtime are happy with that because they treat the output as text, not as elements or as a tree. Whereas in Blazor, everything we create is ultimately a tree or like an instruction kind of thing. So in Blazor, your HTML actually has to be correct and well-formed. And the compiler needs to be able to understand all of the structure of everything that you type in. My friend Ajay on the Razor team, quick shout out to him, did a massive amount of work in order to bring up the HTML parsing support up to scratch for Blazor. When we started the Blazor effort very early on, when it was an experiment, Steve's first prototype just grabbed an external NuGet library. Which one was it?
Yeah, we use AngleSharp.
AngleSharp. We grabbed AngleSharp, which is a great library.
Yeah, it is.
Steve grabbed AngleSharp off NuGet and was like, I can do this. And we had to retrofit that for the real compiler, but for a long time we sort of continued in this mode of like, well, we bolted this external HTML parser onto the compiler and had like an adapter layer. So that was a massive amount of work to ship Blazor. Probably took one engineer about like a year to a year and a half to bring that up to scratch. In terms of understanding C# in Razor, you've got your embedded C# statements in Razor. We understand like just enough C# to get by. We're kind of close enough for jazz. The reason why we sort of take a minimal approach to that is if you think about it, like C# is changing every release. C# is having stuff added every release or new options or new flavors of syntax. We don't want to try and understand them all inside Razor if we don't have to. We don't want to try and keep up with all of the C# changes inside of the C# language if there isn't a need to do it in Razor. So you could sort of think about when the parser is looking at the document, we find an @ symbol, and we basically try to skip over the rest of that text without understanding it deeply because we don't really need to. We don't really benefit from it. It's not part of the programming model, which helps us. There are a whole bunch of C# constructs that we need to understand in detail, like for each and if and things like that. So if you look at Blazor, you like writing Blazor code and you're going to have an unordered list, you say ul for each or ul at for each. We have to understand the syntax of for each enough to represent that as like a for each in the Razor code base in order to do the correct thing. Lastly, what's special about the parser is that we break some rules. I did mention that I'm a mad scientist. There's a really interesting case that we'll look at today about how we break the rules. We need to know basically all the components up front in order to do correct parsing. The reason being that the syntax of attributes is different depending on whether or not something is a component or an HTML element. So when we look at your text, we need to know, is this a component or is this an element in order to do the correct thing? It's not really a good language design practice, but HTML is not really a traditional language either, and it's too useful for us not to do it. About the code generation phase of Razor, or some of the other sorts of things that we do, we get to know all of your components and what their types are and what their parameter types are as inputs to the compiler. We need to do that for a bunch of semantic features in the compiler code generation, like event handlers and event callback and those kinds of things. We can't really know how to do the right thing from a code generation point of view unless we know the types of all the components. Generics because we support generics and generic type inference in Razor, and we will do an example of that, make that very tricky because there are cases where we can't know, or we have to rely on type inference, or we have to rely on overloading. This also kind of breaks the rules, but it's a little bit of a too useful thing for us to not do. We'll also look at some examples of how our code generation strategies rely on overloading, because I mentioned that we know the types of components and their parameters, but we don't get to know the types of C# expressions. So if you open up a code block and you define a method and you start typing inside that method, the Razor compiler doesn't actually know anything about the types inside that method. We just get to see the text, which leads to some sort of complicated machinations as a result, which will maybe bend people's minds a little bit. So with that, we're going to do some examples. That's all the slideware that I've got for you. And to do that, I have built the world's worst IDE. So this is the world's worst IDE, and it's for Razor and for Blazor, and it kind of only specifically does Razor and Blazor. And the naming here is a reference to godbolt.org, which is a famous C# and C++ compiler website that you should check out if you're interested in native code. So if I flip through, I can see that for this document, I've got all of the things that I talked about. I've got the syntax tree, I've got the intermediate representation, and I've got the generated C#. And I want to show a couple things about the syntax tree. Trust me that this banner component has got a message and it's got a loudness. So there's a banner component that we've defined here about a sad crying clown. I mentioned there'd be jokes. Cool. And so let's take a look at what's in the syntax tree for this. And I realize that this is kind of hard to read, but this is the code of the matrix. This is the thing that the people working on the compiler sort of interpret and view in the debugger. And the thing that I want to highlight here is just how much structure and just how much detail there is for this. So for this image alt, a sad crying clown, we don't even have a source element on this image. You can see that we found a markup element, we found a start tag, and then we break up all of this text into individual little chunks. So we've got the alt, we've got the equals, we've got the quotes, we've got the values. All of this stuff gets decomposed at the finest level of detail because we need that to represent in the structure of what we're going to generate as output. If we flip over to what the output looks like, there's a bunch of generated stuff to do with namespaces and file paths and things like that. The output of that is this. We've got this HTML string here, and you can see that we've actually taken all that stuff apart, and then we've put it back together into an HTML string. So you wrote a line of HTML in your Razor file. We ripped that apart into 100 pieces, and then we put it back together. We successfully put it back together into a single line of HTML. Bravo, that's brilliant. So what's going on here? Why would we bother to do this? The reason is we have to, in the compiler, take this apart in enough detail to A, make sure it's correct, B, look at what are you doing in here? Is this all just static text, or do you have some expressions, or are any of these attributes conditional? If you put a Boolean value in an attribute that makes that attribute sometimes appear and sometimes go away, we've got to know all that stuff before we can turn this into a single markup string. The reason why we would turn it into a single markup string is, well, it's just more efficient that way. So this add markup content becomes an instruction that goes to the runtime that says, hey, I've got a block of markup, and it contains no dynamic content. So when you're updating the DOM, you can either add or remove this thing as one piece, because it's always one piece. And that's analysis that we do in the compiler. Likewise, we can look at the invocation of a component. And if I flip back over to the syntax tree here, we can find this. I'll just search for it. So you can see that we've got we call this a markup tag helper element. So people might be familiar with tag helpers from server-side ASP.NET Core. In the compiler, we represent tag helpers in Razor and components in Blazor the same way. But there's kind of a mishmash of features that they share and don't share. So we represent the start tag of this. We represent all the attributes to it. So we've got an attribute here, and we've got the text, a sad crying clown, that's being passed to it, and those kinds of things. So we basically take it apart and generate the same kind of structure here that we talked about. On the lines of breaking the rules, which I mentioned, one of the questions that we get asked a lot about Blazor that I think is a really interesting question that has a really deep answer is for this loudness attribute. if we compare these two, you can find that here. Inside of here, we can see that we've got an attribute value, and it's text, which is wrong, so I think this hasn't updated. Just give me a sec here. I think my IDE is bugging out. But anyway, what I wanted you to see is that we've got a C# expression here inside of this. We've got a C# expression here inside of this attribute. And this is actually an integer. We know that this is C# code. If I wanted to come in here and instead of 11, I wanted to say 10 plus 1, that would compile and that would be valid C# code. And you wouldn't see in the output 10 plus 1, you would see 11 because this is an integer. And anything that you type in here is C# code. If you look at this message attribute instead, I can type in here and it's just text. It's not C#, right? So I don't have to have a variable called A or a variable called sat or any of these things. If I wanted to reference a variable here, I would have to do it like this. I have to have the @ sign to get into C# for this attribute, and I don't have to have the @ sign to get into C# for this attribute. What's going on here? The answer is, well, we do a special thing for strings. So anytime you have a component parameter that's a string, that effectively gets special handling in the compiler and in the tools, in the editor, in the IDE. And the reason why we do that is because the alternative would just be terrible. So imagine that you had to put the @ symbol in and then put in a C# string every time you wanted to put a string inside of an attribute to pass to a component. Well, that would look like this. So you'd end up typing a whole bunch of quote, @ paren quote, and then your string, and then the reverse on the way out. And that would just be terrible. So this is a case where we actually break the rules of language design. Like, you get different syntax inside of this attribute depending on what the type is that it's being bound to. It's not really a good language design thing, but the results, if we followed the rules, would actually be really bad. So we do that for you. And it's kind of complicated to make that work. But we do it with love. So it's because we value you. Likewise, I want to look at this one. This is another example that's just got some blocks of like HTML in it. And I'm going to flip over to the intermediate representation, which will probably be the most readable way to look at this. And over here, you can see that we've got a markup block, and we've got a markup element, and we've got HTML content, and we've got all this kind of stuff here going down to this C# expression for this second paragraph. So our first paragraph, which is an important announcement about peanut butter, is all one markup block, as we can see, or it's two markup blocks, as we can see. And then our second paragraph here, or our second p tag here, is you can see that in the intermediate representation, it's broken up into like this big series of things. We have an element containing some text, containing an expression, containing more text. And the reason why this is basically is because of this datetime.now in here. So you can see that putting some C# into this big complex markup structure, this is that optimization that I talked about before, where when we can, we represent chunks of markup as static text because it's more optimal for the runtime, it's more optimal for the generated code. But when you put generated C# in there, we have to represent that as all of its full structure and generate that out into the C# with all of its full structure for the runtime to do the correct thing. And these are some of the things that help Blazor work efficiently when you update something. So like if you just kept refreshing this page, or if you just kept reloading this page, triggered re-renders on this component, the value of datetime.now would keep changing. We wouldn't generate that whole string. We wouldn't turn this entire paragraph into a string, send that entire paragraph down to the client, and then paint that entire paragraph into the DOM. We would literally just update this inside of this EM tag. And you're seeing that optimization in work in the difference between how this first section of text is represented in the intermediate code versus this section of text that contains some dynamic code. If we look at that in the C#, in the generated C#, you can see the same thing, that we've got an add markup content here with this big block, whereas for this other text, we've got this add markup content here with like a lot more stuff going on in order to capture that dynamic expression. So let's look at our next example. And I'm actually going to jump out, for these more significant examples like this, I'm actually going to jump out to VS Code so we can have a better view of this. But I've got a to-do editor here, and I've got this onSubmit handler. So I've got a basic to-do list sample with an onSubmit handler, and I'm passing in this method to that onSubmit handler. So when this to-do editor submits itself, I'm going to add my item to my list. Pretty simple, pretty straightforward stuff. We know if you've done any basic Blazor kind of stuff, we're always telling people, you know, if you want a simple answer for how to pass commands and events and things around, the type you're looking for is event callback. Event callback has got some special runtime smarts in it that will help the system know when to re-render the right stuff, and it also handles a bunch of different things to do with async. So let me jump to VS Code, where I have got this text sort of fanned out for you to look at. So here's my index with my to-do editor, and this is my generated code. So here's our for each loop. We understood the C#, and we were able to keep going? OK. Here's our for each loop. We're able to understand the C# and sort of put that out into the output. Inside of this loop, for each element, we're adding an li tag, which is represented by this. This is the opening of the tag. We're rendering the item, and then we're closing the element. And then we're going to call to the to-do editor. So when you call to another component in Blazor, basically you can think of that like a function call to another class. We're going to say, OK, I want a to-do editor to appear here on the page. And then the next set of things that are going to happen with that to-do editor is, well, we're going to wire up all the parameters that need to get passed to it. And that's what you're seeing in the generated code. This very complicated, very long set of string here is how we pass parameters to other components. This is how I live my life, Steve. So what is going on here? Can I help unpack all of this craziness? The answer is that, well, this API add attribute is untyped. So it accepts an object, which seems really flexible, seems really good. And it is really good, unless you want to get good errors when you pass the wrong thing. Because whatever expression you type inside that onSubmit attribute is probably convertible to object, right? So because it's probably convertible to object, but we know the type, we know that the type is supposed to be an event callback, we insert calls in the generated code to this type check method. If you were to look at this type check method, it's just the identity function. So it's a method that it's a static method that takes one parameter where we tell it basically, you only accept a parameter of this type, and then it just immediately returns that value. Its entire purpose is there to make the compiler happy and make it so that you actually get an error about passing in the wrong type if you have done so, which I would not advise. The next thing that you'll see is there's this event callback.factory.create of system string. So going back to our code example here, our to-do editor accepts an event callback of string, but we are passing in a method. We're passing in this onSubmit method. And it's a void method that accepts a string. So the signature of that method is basically action of string, right? We need a way to convert an action of string into an event callback of string. And that's what this event callback factory does. The other trick that event callback factory does is it takes an argument as the first argument that is the receiver of the event. This is basically the magic that makes Blazor's event routing and Blazor's efficient re-rendering work. We're passing some information into this event callback that says, who is the owner of this event, or who's the person that's going to respond to this event. So in our case, the index form is the one that wants to respond to the event. And so when we create an event callback, we pass into this argument so that we're able to sort of bind that up and say, when you dispatch this event, dispatch it to this component. Lastly, this event callback factory method is overloaded. So in addition to accepting action of string, it would accept action, it would accept func of string to task, and it would accept func of task. And that's the magic for how all that sort of works in Blazor. So if I came back over to this example and I said, OK, this is an async method now, that would just work in Blazor. An event callback factory is the magic of how that's done. It's just overloading. So there's 4 overloads of that method, and then you're able to pass in those really flexible signatures and get whatever you want going through there. Let's do one other example. How are we doing out of time? Are we almost out of time?
We've got 1 minute left.
We got 1 minute left. So I'm going to do one more example, and I'm going to go through it as quickly as I can. So I've got a templated list here, and my templated list is a generic component. So my templated list has got a type parameter, and it's a generic component, and it is genericized on the type of item that I'm passing in, so I can pass in a list of some item, and then I can specify how I want to display each item. That's that render fragment of item content. And you can see that at work in here. This kind of component is nice because you really get tired of writing this kind of boilerplate. I want to show a list of something, but I want to have a special message if the list is empty. Do you want to write that all over the place, or do you want to write a 30-line reusable thing? So what does this look like when we use a templated list without specifying the type and with specifying the type? Because Blazor has type inference as a feature. So let's take a look at that. And this is in the generated code again. So we can see here that we're calling templated lists, and this is the example where we're not specifying the type. We're passing in the items, and we're passing in some child content where we're basically just going to render, we're basically going to just pass in that template that gets used in the body of it to render the item. On the other hand, oh, this is not updated. Let me give this a kick real quick and see if it updates. Sorry about that, my thing bugged out. There we go. Okay. You can see that once type inference gets into play, we generate this little static helper class here. So there's a type inference class that shows up in your generated class. And the reason is because in C#, there's no way for us to call open component unless we know what type is going to go into here. In the example where we're relying on type inference, which is this one, we don't know what to pass in there. So we create a static method that then we call, and then inside of that static method, which is a generic method, we can call templated list of t inside of here. Whereas in the case where you've explicitly specified the type of something, we can just do it. It's much more straightforward. So Blazor has generic type inference. It's really powerful. It's also really hard to get right and kind of changes the semantics of a lot of things or changes the implementation of a lot of things in a really dramatic way.
Cool.
Yeah.
All right, awesome. I hope that your minds are filled up with excitement about what you can do with the internals of the Blazor compiler. I think that's all we've got time for. So
Yeah.
I hope that's been fun and useful to you. Yeah, if you've got any questions, come and chat to us. But otherwise, I hope you enjoy the rest of your day.
Yeah.